There's a YouTube channel with over 1 million subscribers, and one of their videos has more than 600,000 views, hundreds of LinkedIn posts, and dozens of web pages, and they all share one thing in common. They are wrong. They show an execution order that makes no sense, none at all. It's crazy. So let's look at how it actually works. I am making this video because of a discussion I had recently. And by discussion, I actually mean a fight. A Java developer was arguing with me about SQL execution order. And to prove himself, he showed me a YouTube video with more than 600,000 views. Later, when I told him the video was simply wrong, he googled a few web pages and they all said the same thing. And that's when I realized this mistake is everywhere. Not because people are dumb, but because this simplified diagram is easy to share and easy to remember. The problem is, it has nothing to do with how databases actually execute your query. If you care about performance, if you are serious about data, if you want to understand how engines actually work, you need the real picture. Here is a screenshot from that YouTube video. They use the classical wrong order: from, join, on, where, group by, having, select, order by, limit. This is a LinkedIn post titled Important SQL Interview Questions. And the very first thing it shows is again the wrong order: from / join, where, group by, having, select, distinct, order by, limit / offset. And if you ask Google for SQL execution order, the very first result, probably a paid one, takes you to the Code Academy, where you find yet another version of the same mistake: from / join, where, group by, having, select, distinct, blah blah blah. And they even write this where clause: after the dataset is assembled from the source tables and joins, SQL filters out rows that don't meet the where condition. We'll come back to this later, and I'll show you exactly why this is a complete nonsense. But for now, let me show you one example query and the real execution order for it. First, what does this query do? We want to return the average movie score per country, how viewers rated movies from each country. We only care about movies with a budget higher than $5 million. We only want countries that have at least 11 such movies. That's the having clause. And finally, we want the result sorted by country name. It's important to mention that we have an index on the movie table. This index covers country, score, and budget. And B3 index always returns rows in key order. Most tutorials tell you that the select and order by are supposed to be the last steps. But here is what actually happens, one of several possible execution plans. The engine has to get the data first. So in this case, it starts with the index, not the table. As it reads the index entries, it immediately applies the filter budget greater than 5 million and removes all rows that don't match. That already satisfies where clause. Because country is the first column of the index, the rows come out already ordered by country. So the order by clause is satisfied right after from the start, before the engine even begins grouping. No extra sorting is needed as long as the following operations preserve the order. This index contains all the columns used in the query: country, score, and budget. And here is something most people don't realize. The database reduces the columns it needs as early as possible. Once the filter budget greater than 5 million is applied, the budget column is no longer needed. So the engine drops it immediately and continues only with the country and score. Column reduction does not happen at the end. It happens as early as possible. In the diagram, we call this step select, and in database theory it's called projection. And here is the crazy part. After the very first operation, scanning the index, we have already done the from clause, the where clause, order by clause, and the select. The classical, or better say the wrong diagram, says these steps should come last. Because the rows come out already sorted by country, the database can perform the group by as a stream and easily calculate the average score and the count. Normally, a database needs to sort the data or build a hash table for aggregation. But here the sorting is already done, so it can simply aggregate as the rows arrive. After aggregation, the engine checks the having clause, count greater than 10. And because both aggregation and having clause, in this particular case, preserve the original ordering, the result is still sorted by country from the very beginning. So no extra sort operation was needed. That's it. This one example destroys the idea of universal execution order like from, then where, then group by, then having, then select, then order by. I have good news and bad news. The bad news is SQL has no fixed execution order. Every database engine is different. The good news is you can learn it. And if you learn it the right way, you will be ahead of most developers. It's really not that hard. Just remember that the database always chooses the strategy that minimizes work. Let's go back to one of the claims from the video. They say that where comes after a join. But why? Why would any engine perform a join before applying a filter? It doesn't matter whether the database uses an index or a full table scan. It always tries to filter out rows as early as possible. Even without an index, the engine tries to apply the where condition while scanning the data, not after joining everything together. Similarly, why would an engine carry extra columns all the way to the end? Operations like grouping need memory, and fewer columns mean less data and less memory. As you can see, databases make reasonable choices. They simply try to make the working dataset as small as possible. So, I hope you now have a much more accurate picture of how SQL execution really works. My goal is to give you high-quality, detailed explanations, not just what happens, but why it happens. And that sometimes means my videos go a bit deeper and take a bit longer, but I truly believe the clarity is worth it. If you want me to break down the real execution order for the query from that popular video, let me know in the comments. I'll be happy to make a follow-up. Thanks for watching, and if you want the next SQL myth destroyed properly, hit subscribe. Otherwise, I'll assume you still believe the classical execution order diagram. Take care.